Welcome back to another lesson on trigonometry. Today we're going to talk more about applications. We'll use another example from surveying. This time I'll introduce the law of sines. Now suppose you are standing across a river from some point on the other side of the bank, and you want to know the distance between where you're standing and there. Well, if we draw another point down here, and let's say we measure that as 100 feet. Notice how this forms a triangle. Now my diagram is not to scale, but suppose you also measure this angle is 60 degrees and this angle is 40 degrees, which can be done with surveying equipment. In general, a triangle of angles A, B, C and side lengths lowercase a, b, c, notice how they are opposite, c, c, b, b, a, a, can be represented like this. Now the law of sines states that sine of A divided by A is equal to sine B over B, which is equal to sine C over C. There's a constant ratio between these three terms. Because the ratio is constant here, we can also take the reciprocal. A over sine A is equal to B over sine B equal to C over sine C. So depending on the application, one form may be easier to use than the other. Now in our example here, well, I'm given two angles and a side length. Because there are 180 degrees in a triangle, I know that this is equal to 80 degrees. Simply put, down here I have written 180 degrees is equal to 60 degrees plus 40 degrees plus 80 degrees. You can verify that for yourself. Let's solve for side length C. Now since I'm solving for a side length, I'll choose the second form where C is already in the numerator. So here I've set up my ratio. 100 feet over the sine of 80 degrees, side matched with the opposite angle, is equal to side C divided by the opposite angle, 40 degrees. I can multiply both sides by sine of 40 degrees to get C is equal to sine 40 degrees times 100 divided by sine of 80 degrees. I'll plug this into my calculator, entering each term separately. And I get C is equal to 65.27 feet. Well, that was simple enough. For your homework, I'd like you to find side length B, where B is this distance here, using the law of sines. Put your answer in the comment section below. Now, to bring it back to the practical aspect, remember how I said there was a river separating us from this object? It could be a tree or a flagpole or any other landmark you want to choose. The advantage of trigonometry is that we're not directly able to measure the distance from here to here, because that would involve crossing a river in this case. So trigonometry as applied to surveying allows us to find distances by indirectly measuring angles. Hopefully that makes a little more sense as to why trigonometry is so important for surveying. Thank you for watching this video. I hope you learned something. I'll see you next time for another lesson.